George Tyndall, and I'm back again. I'm here to talk about a few things. One is I'm going to talk about the planet Mars, and I'm going to give people a more in-depth view of it than what any of your experts and NASA can do, because they don't have the stuff that I'm looking at. So I can come up with a better idea of what's going on. And then I'm going to talk about the magnetic field and the cores in the middle of the planets. And I'll explain that, because James Hutton's theory of rocks, or the rock cycle, whatever people want to call it, there are errors in it, or it's completely wrong. Now, I will explain how I know this stuff. Okay. We'll start with my findings first. Okay. And these are my findings. Like I said, people don't have to listen. People don't have to believe. I don't care. I'm putting them out there. And then 10, 15 years down the road, when NASA finally gets all their stuff back, I will have already told people. So, now, I know this for a fact. Mars was completely covered in water. Do I know if everything was covered in water? Maybe the tallest volcanoes weren't, like the one they call Olympus Mons, because it's 14,000 feet high. The top of it may not have been covered. Okay. Now, the lava flows from on Mars, the ones that you see, and basically the way you see Mars is everything that's left over is what was left after all the water either evaporated on top. Now, they say that there's a body of water underneath the planet, and that's very possible, especially if it works like the Earth does. The Earth, the upper level circulates with that bottom level, and it pushes the warmer water out. And it's one of the processes that helps keep the core cool. But people got their own view on it. Now, the lava flows from the underwater eruptions. And how do I know this? Okay, right here. Those are outcroppings on Mars, okay? And the reason why they're flat on top like this is that's actually a gigantic lava flow. And it was on the bottom of the ocean, and it lifted up. Because underwater volcanic eruptions, they lift up off the ocean floor. Okay. Now, Olympus Mons interior crater and outside crater are like powdery smooth. Okay. I'm not going to say whether it was completely underwater, because I don't know. But what's left, and how did it lose its water? Well, probably when it lost its magnetic field, it probably evaporated. There probably wasn't any way to keep it on the planet. All the basalt oxidized after the water was gone. That's why you see what you see. Basically, what you're seeing is all that powdery, gritty stuff that's red on Mars. Yes, it's oxidy, but it would have been like Mars sand. And you see so much of it, so that right there tells you that there was a lot of water on the planet. And I'll get to the basalt on Mars here in a second. And I will explain how all that happened. Okay. The way all the lava flowed and cooled so fast around the lava flow picked up pebbles and other things from the ocean floor and encased them inside the lava. And I will explain that. I will show you a piece and I will explain it. Lava flows, as I said before, raised up off the ocean floor. That's why you see what looks like a ramp. Okay. This is why Mars has a lot of metamorphic rocks and solid metal rocks. Yes, Mars does have solid metal rocks. And I'll explain that too. The pressure of the water on the lava flows pack the material flat and tight like concrete. That's why people are saying the stuff that I'm showing them is concrete. Because it does look like concrete and it does resemble concrete. And Mars does have it. That's why this uplift resembles concrete. That's why it's flat on top and it's rough on the underneath. And I'll show you. The lava is a mixture of red, green, and gray colors. And this is fact, but this is something that they can't see because they can't get up close and they can't look at the inside of a piece. And the big point is, this is why you won't find life on Mars. Because if most of them were underwater volcanic eruptions, the water would be infested with sulfur and chlorine, and no life forms would have ever been able to survive off of that water. Not even if there was land. That type of water. And you can look up what Mars is composed of. And it'll tell you there's a lot of sulfur and there's a lot of chlorine. Okay, you're not going to be able to inhabit the planet. It's just not going to happen. But you people out there at NASA waste everybody's money. I don't care. Now, how do I know most of this stuff? Okay, right here. Okay, supposedly this is what people are saying is concrete. Okay, and I'm going to go into depth why it is not concrete. This is exactly the same as this type of rock right here. It's exactly the same. The only thing, it was blackened on its way to Earth. Okay? And there was a problem with the mesosphere. The mesosphere, after it gets polluted with so much smoke, it drops. And it isn't able to burn stuff properly. And people are going to find this out, and they're going to find things out the hard way. And that's the way it is. Now, I will explain this. Why this isn't regular concrete. Okay. You can look at this stuff. How black it is, how black the pebbles are, and stuff around it. Okay? Every piece, all the way around it. All the black pebbles, all the way around it. But when you go to the inside and you break it open, it's the type of pebbles in there, and I found one pebble. Okay. Regular concrete would have had pebbles spread out through the outside and the inside. We don't make concrete like this. But what this is, and the top part of this right here looks like this on the ones that have more of the red on it. The colors were somewhat burned off. And that explains that problem. But you look at the inside here. Okay? This right here is either 2 or 3 different lava flows all connected together. This is a close-up. These 2 pictures are close-ups. This color that you get right here, this is aluminum, magnesium, and iron. Whether people want to believe it or not, And those are the three elements that are abundant on Mars. And I worked in an aluminum plant. I know what aluminum ore is, and aluminum ore has this color. Now, whether people want to believe it or not, I don't care. But if I'm correct on this, when the lava flowed, it pushed all the pebbles to the outside. That's why you see them all on the outside, because when the lava went over the bottom of the ocean part, all those pebbles became embedded. Everything became embedded around the side, but that's why you don't see really anything here. And these little interesting light pebbles right here, those are on Mars too. But the interesting fact that I'm finding out, that a lot of people can't find out, is the pebble that I pulled out of the center of this. The pebble I pulled out of the center of this is solid metal. It's solid iron. Now, like I said, there's going to be people out there they're going to say no, and whatever, and that's fine. You're allowed to do that. I am a reasonable person. Experts are going, no, it doesn't happen. This is the way it is. It can't happen, and they're full of crap. But when I broke that piece open, the complete inside of it, there's virtually none of these. None of the outer pebbles that you see. Right here, all these outer pebbles, there's nothing like that on the inside. And the real fascinating thing about it is, because you don't have it and you don't do what I do, when you put this in water, it smells exactly like chlorine and sulfur mixed together. It stinks. It almost makes me want to throw up. That kind of evidence you can't get from looking at a picture. And you can look it up. You can look it up online. Okay? You can't smell a sulfur chlorine smell in a picture. It just doesn't happen. And I found some other rocks that stink a lot worse. But regular concrete, when you stick it in water and pull it out, it doesn't smell like sulfur. I poured cement slabs. Now, I'm putting my findings out there. If people want to believe it or not, that's their choice. Okay? I'll leave it up to you. But I'm telling you that the stuff from Mars is already here. And that's plain and simple. Now, another problem that they can't figure out the things with the magnetic fields in the Earth. Well, like I said, if your theory of rock, because somebody just sit there and went, it's like this, and didn't actually make a trip to the Earth to see if rocks are actually made inside the planet, which I highly doubt that they are, from what I'm finding. You'll take that and you'll go to Mars. And you can't use that rock cycle on Mars because Mars is a different planet. It's a different planet, different composition. All that stuff that is red on Mars, it's this type of basalt. Okay? When this type of basalt gets wet, it starts to crumble. It starts to flake off. And if it's underwater, yeah, water's going to break it down over a period of time. That's why there's so much red oxide on the bottom, is because it broke down a lot of the basalt. But like I said, whatever. They're going to figure this out. They can get all the way to Mars and they're going to figure out, well, we screwed up. We can't make Mars an habitable planet. And they never will. They never will because of the composition. But that's that. Now, getting to the core of the planets. Heat generates movement and power. Okay? You boil water. It heats up. The water moves. Same way in the radiator in your car. All right. Now, the core of Mercury is 2,900 degrees to 3,300 degrees Fahrenheit. It has a weak magnetic field. Okay. Mars core is 1,320 to 2,570 degrees Fahrenheit with no magnetic field. Okay, those two things tell me right there. Okay, the higher temperature has a little weaker magnetic field, but the lower temperature has no magnetic field at all. So based on those two planets right there, in order to have a magnetic field, especially a strong one, the temperature in the core has to be high. If the temperature in the core drops, I got it figured right around maybe 3,000 degrees or below 3,000 degrees, you lose your magnetic field. Whether you people want to believe it or not. And you can compare the core and the core temperatures and the magnetic fields on Jupiter, Mars, Earth, Venus, and Mercury. And you'll come to the same conclusion when you figure that out. That's why Jupiter's core is 43,000 degrees Fahrenheit, has a strong magnetic field. Earth's core is 9,800 degrees Fahrenheit, a strong magnetic field. Venus's core is, 9,220 degrees Fahrenheit, but it has a differentiated magnetic field. Okay, its magnetic field is a little bit different, but it still exists. So I'm telling people right now, and the Earth's core, from what I looked up online, they say that the Earth's core is cooling. Now, how long does it take to cool to get to that point? Okay, if the Earth's core was to cool to 3,000 degrees or below, it'll drop the magnetic field and the planet will look like Mars. Whether you experts want to believe this or not. It's simple. It's right there. These planets tell you about the magnetic field in the core. All you have to do is put everything together and look at it. And like I said, me being correct about this, like I said, the thermal magnetic energy that's generated that goes to the core to power the core. Okay, if that temperature drops down, that thermal magnetic energy is going to cease to exist because it's thermal, it's heat. That's why your magnetic fields disappear when your core in your planets, the temperature drops too low. And then there isn't anything to generate the heat to be able to make the lava and the volcano eruptions. Basically, all the volcanoes on Mars are plugged. And this is the truth. Whether people want to believe it or not. You know, just because I may not have a bachelor's degree or an education in this and that, doesn't mean I don't know what 2 plus 2 is. Or I don't know what something is by looking or observing or comparing information. Now, if people actually want to learn something out there, they need to start going this route. And you can't just have in your mind that this doesn't happen, because if you don't factor the doesn't happen into with the can happen, you miss all of this. But I'm telling you, and I'm telling you like it is. But like I said, if people want to spend billions and billions of dollars to go to Mars, waste taxpayers' money to find out that you're never going to be able to inhabit it or live on it or grow anything on it, do it. Okay? That's all I have to say.